Okay, let's start with the presentation. Hello, everyone. Today we'll be presenting this webinar by my own. For those who don't know me, I'm Bernardino Martín. I'm product owner of pvDesign, and I'm working in the generation area. So my focus is the PV plant itself. As you may know, we have our software is growing, and we have different parts. So we have the interconnection side, the battery areas, also the energy storage, and the PV plant. So I'm focused on the PV plant. My main tasks are to define the requirements of the new features that we launch every week almost, and also to maintain the backlog for the new features through the feedback that we receive from our customers. Today we're going to do a case study in RatedPower, where we will find the optimal tilt angle using fixed structures. Okay. We are going to study 2 sites, one in Germany and other one in Spain. Also, we will assume different costs for each of the projects, and we will be using the new tool, the tilt angle in batch mode, that I already presented in the last webinar. We will be also doing a comparison using the comparison tool of pvDesign. We'll export the data with the new export functionality that the new export tool or the new export feature that we launched also last quarter, and we will do analysis in Excel. Okay, so basically the tilt angle in batch mode is this tool where you can define several tilt angles. You will have to define a minimum tilt angle, a step value, and a maximum tilt angle, and the pvDesign is going to generate all those designs with all those iterations. Okay. There are 2 ways of using this. You can use you can fix the pitch for all the iterations. So you basically fix the pitch and then change the tilt angle, or you can change the tilt, but also recalculate the pitch based on our criteria. So our criteria to recalculate the pitch is to ensure that we don't have shades in the winter solstice during 4 hours. So 4 hours of non-shading production for the worst day of the year, the winter solstice. Okay, let me show you also a bit this tool in pvDesign. Okay, so this is the case study that we are going to see later for Germany. Okay, so to use the batch design tool, we have to go here inside the design process to the option run batch, and here we'll see the 3 options that we have currently. We have pitch distance, DC-AC ratio, and tilt angles. Okay, and here we will define the minimum tilt angle, the step value, and the maximum tilt angle. Here we can also define the pitch distance, for example, 7 meters, and refresh the table. So in this case, we are fixing the same pitch distance for all the designs. And we just have to click on generate design and generate all these iterations. And the other option is to recalculate the pitch distance. So in this case, you can see that we are having different pitch distance for different tilts, because as the tilt increases, the pitch increases too, because we are recalculating those values based on the shading angle limits for the winter solstice, as we saw before. Okay. Once we have those iterations, we will be fixing the pitch distance and launching different batch, changing the tilt distance, the tilt angle, and fixing the pitch distance. We'll be generating all those designs. Then here in the historic view, we can see all the designs while they are being generated. We'll select them, save them, so we can access to the comparison tool later. So we'll be doing this with different pitch distances and the same tilt angles until we reach our all the iterations that we want to do, and then we will go to the design page inside the project, and we will compare all the designs using the comparison tool. And here we can see a table with all the results. We'll be filtering the results that we want to study, that are the specific production, the energy, the total energy, and the LCOE mainly. Those are the three parameters that we want to study today. We will also want to see the tilt angle, the pitch, and the GCR. And once we have all those values selected, we will use in the export tool, so we can directly download an Excel file with all this data, okay? Here you have an example. Okay, this Excel file is the analysis that we're going to do. So with this data, here we have all the data of all the designs that we want to study today. We'll be generating some tables, some plots, so we can basically see which design have the best parameters. We can do also some 3D surface plots to see it better. Okay. I will jump back to the presentation to see the results of the case study. So let's introduce first the cases. So we have two sites, as we saw already, one in Germany, one in Spain. We'll be using the same equipment in both designs. So we'll be using monofacial modules for the and string inverters, and also 2P or 2-portrait fixed structures. Okay. We'll be using different capex and opex templates based on the country. So in Germany, we'll have a higher capex and higher opex than in Spain. And in both cases, the capex will be based on Arena templates, and for the opex we have two parts: one based on the peak power that we'll see now, and another fixed opex based on the land cost. Okay, this second opex is really important for the analysis. And as I already told you, we will be using these tools here: batch, design, comparison tool, and export. So let's start with Germany. Here we can see the terrain. So we have a terrain that is quite flat. We have 20 hectares. We have 1,000 kilowatt hours per square meter of global horizontal radiation. We will assume a capex based on the peak power. So we are going to launch different designs, changing the pitch distance. So some of them will have more peak power than others. So the cost will change depending on the design. Same for the OPEX. We have an OPEX that depends on the peak power, but we will also add an extra OPEX based on the land cost, okay, the cost of terrain. In this case, we exaggerated a bit the cost here, so it's quite expensive, 6,000 euros per hectares per year. And we also define an escalation rate, so this cost increased by 3% every year. This cost is fixed for the project, so it doesn't depend on the installed capacity as it's written here. So it doesn't matter if we install one structure, let's say, or 2,000 structures, this fixed cost will be the same for every year, okay? Because it depends on the total available area. So let's see the results. Here we can see that the designs that generates the maximum amount of energy is the design with the smallest pitch distance and the smallest tilt angle. So in this case, as we are not considering the cost yet, we are only checking the energy. We are installing more power when reducing the pitch distance to the minimum value, 5 meters. And then also we are taking the smallest tilt angle because it's the one that generates less shades. So for this case, we will have almost the same amount of peak power installed, but for these cases, we will have a lot of shades between structures, okay? So in terms of energy, the best design is the one with the lowest pitch and the lowest tilt, okay? But this is probably a very expensive design because it's not very efficient when talking about energy per peak power. So if the specific production is really low, and also the sun rays will never incident perpendicular to the module as they are really tilted. Okay, they are really flat. So if we check here, we can check the 3D plot that we did also in Excel. Okay, so here we can see that this value for the lowest pitch and the lowest tilt is the one that generates more energy. Okay, let's check also the layout, how it looks like for this case. So here we can see the total energy value is here, sorry, 29 almost gigawatt hour. But if we check the layout, we can see that there is no space for the operation and maintenance, so it's not realistic, this design. Okay, but it's the best one in terms of energy. So yeah, imagine if you have to clean those modules in the middle. But if we check the specific production, we can see that now the results are different. So this design, that was the one that was generating more energy in total, is not the one, the best one in terms of specific production, but the best one in specific production is the one of pitch distance of 12 meters, so the maximum one in terms of pitch, and a tilt angle of 25 degrees. Okay, let's check this in 3D also, like with the surface. So here we can see that we have an area here, a really flat area, where we have the optimum pitch and tilt around a tilt angle of, yeah, we saw it here, 25, and a pitch distance of 12 meters. In this case, I'm almost sure that if we keep increasing the pitch distance, we will get different results. So let me go back to the previous slides. So the areas we saw was getting flat here, but if we keep increasing, it will be increasing a bit, even more, because we are not considering the cost of the land here, just the specific production. So the higher the pitch, the less shadings you will have between structures always. So it will go always for the highest pitch. In this case, it's taking also the tilt of 25, because it's a good tilt to avoid shading between structures. If we keep going beyond 25, we keep increasing, we can see that the efficiency starts to decrease as we start having shadings between structures. Okay, it will be interesting also to generate other plots, not only taking into account the energy, but also the near shading losses or other kind of losses to check it better. Okay, let's go for the layout. So here we can see the layout of this case, the one of high specific production with a GCR of 36% and a tilt angle of 25. We can see that now we have enough space to go between structures and do the maintenance of the modules. So this is a more realistic design. But as we were talking before, we are not considering the cost of the land. So let's check the design from the cost side. So what happened if we consider the OPEX that we were talking about, that was a fixed OPEX that was really expensive, the land cost. So we will see in this case that the best design in terms of LCOE is the one of a tilt angle of 15 degrees and a pitch distance of 7 meters. So it's a midterm between the one that was generating more energy and the other one that was having the best specific production. Okay, so if we start increasing the cost of the land, we will see that we will be going closer to this design, and as the let's say the cost of the land gets cheaper and we only consider the cost based on the peak power, we'll get in closer to the optimum design in terms of specific capacity. Okay, so this is a case where we can see that the optimum design is in the between these two. Okay, also in this case we are only considering the costs. Okay, we're not talking about revenue. This is also an interesting topic that could be analyzed, that maybe in some cases it's better to get a more expensive design in terms of LCOE, but getting, let's say, producing more energy if you have a PPA or the merchant price is too high. So sometimes it's better to have a PV plant with a higher cost and generating more energy, or the other way around. If the energy of the pool and the PPA is too low, it's better to go for a more efficient design. So if we are only considering cost here, okay? Talking about energy and costs. By the way, we did a poll yesterday in LinkedIn, and most of you got the right result. Thank you everyone for participating. And we will do a different poll later here, okay? For the next case study. Let's check here the LCOE plot that we did on Excel. So we can see that the minimum LCOE is here in this area, where we got the 7 meters pitch distance. So it's between the minimum and the maximum value, between 7 and 5. And the same with the tilt. The tilt is around 15. So it was here in this area. Let's go for the layout. So here we can see the design in 3D. We can see the pitch. The pitch is low. It's not really low as the first design, but it's quite low. But also the tilt angle was a bit reduced to avoid shading between structures compared to the case where we were checking the specific production, the best design in terms of specific production. So it's a midterm between both. Okay, let's go for to the recap. So here we can see again, if we focus only on the total energy production, the best design is the one that installs more peak power, since it doesn't matter we're not considering other values rather than the energy. This is the best one. If we consider only the specific production, this is the best one. And here we have a midterm if we consider the LCOE. Okay. As I already told, if we were simulating designs with larger pitch, maybe we'll get a different results here in terms of specific production, like with highest pitch. And also, depending on the fixed cost, we could have different results here, okay? Let's see the next case study. It's in Spain. Here we have, again, a flat terrain. We have a larger area. Before we were talking about 15 hectares. Now we are going with 59 hectares, 50.9, sorry, hectares. A higher global horizontal radiation, 1.8 thousand, almost double than before. Here we have a lower capex and the same opex in terms of peak power. These two costs, as we saw before, depends on the amount of structure that we install, and this opex is going to be fixed, so it doesn't depend on the peak power. Okay. Next slide. Here we can see that in terms of energy yield, again we get the design with the lowest pitch and the lowest tilt as expected. And here we can see the plot is really similar to the one that we saw before of Germany. So the shape of the plot is the same, but the values changes, of course, because we have a larger area and a larger irradiation. So the energy yield is much higher, but it's basically the same plot. In terms of layout, again, low pitch distance, no space for operation and maintenance. And in terms of specific production, in this case, we got a higher tilt than before. This is something that is really interesting, because usually when you go to higher latitudes, the sun elevation is lower, and usually you will be using a higher tilt angle if you have only one row of structures. But as we have different rows of structures as you remember in this design before in Germany, the best tilt angle for specific production was 25 due to the pitch distance that was limiting so we were taking 25 to avoid shadings, no, let's say. But in this case, as the sun elevation is higher, it goes for the 30 degrees tilt. So we are using a higher tilt in Spain than in Germany in terms of specific production, okay? Okay, nothing else to comment here. Here we can see the plot. Again, it's really similar to the other one. The shape And here we have this area where we get the maximum values around 12 meters and 30 degrees. Okay, the layout again, really interesting layout. Enough space, really efficient in terms of energy production. But what happens if we consider the cost, okay? So now let's analyze first the two cases. So in energy yield, this is the best result. In specific production, this is the best result. So now we are going to do another poll. We are going to do it live now, and here you will have to find the best pitch and the best tilt for this design. Just I want to remind you fast here that the OPEX is 2,000 euros per hectares per year. In the case of Germany, was 6,000 hectares per year. Also, we are in different latitudes. The sun elevation here is higher, and so on. So feel free. We are going to launch the pool now. So which one of those solutions you think is the best one for the design in terms of LCOE? I don't know if you can see the poll. Yeah, I think it's open. So we have three options. The first one is a tilt of 30 degrees and a pitch distance of 12 meters. The second one is a tilt of 25 degrees and a pitch distance of 10 meters. This one is between the two that we saw before. And the last one is a tilt of 10 degrees and a pitch distance of 7 meters. Okay. So the first solution, the one of 30 degrees and 12 meters, is the same case as that we got for the highest efficiency production, okay? In this case, and the last case is really close to the one, or is closer, is the one that is closer to the one with the highest energy yield. Let's wait a bit more. I'm seeing your answers here. Okay, I think everyone answered. So here we can see that the solution, the answer was B, the most vote answer. Most of you, 60% of the people, voted that one, and you were right. So basically, we are between both. I think this one was the one with the highest specific production, and this one with the highest energy yield. And when we consider the land cost, we get to a point in the middle. Okay, an LCOE of 46 euros per megawatt peak, per megawatt hour. Sorry. Okay, here we can see also the plot again, and similar to before, but with a lower cost. And also here we can see the final layout. It looks really well. So we have a GCR of 40%, 43%. There is a good GCR, so you have enough space for maintenance. Okay, let's conclude. So as we saw, it's really interesting doing this analysis and taking into consideration the land cost when doing it, because if we don't consider that land cost, we'll see that we always get, in terms of LCOE, the best design will be always the one with the highest pitch distance, and this is not a realistic case as we keep increasing the pitch distance, we will have that fixed cost that we have to consider. Also, something that will be interesting to study in the future is to consider the revenue of the PV plant, or doing a full financial analysis. For example, comparing the return on investment of one PV plant and another one, or the internal rate of return, or the net present value, different financial parameters to do those plots that we were showing. See. Okay, so that's it. Let's jump to the questions. You can you can use the question box to ask your questions. You already have one here. Okay, so here we have one. How can you optimize the performance if land has multi slopes in the north, south, and east, west direction? Mauricio Campos. Okay, so thank you, Mauricio. Let me show you how can we do this analysis in pvDesign. So currently pvDesign doesn't consider the slopes for the energy yield, okay, in terms of energy production. So we assume that the terrain is flat. But let me go for a terrain with slopes here in the demo count. Okay, this one's that I did in Brazil. Here we can see the slopes of the terrain to do this slope analysis. So let me clone this iteration. And here we have the topography tab, where we can define the limits of the structure that we want to remove and the structure installation limits. Okay, so basically, if you have some structures in the north-south direction, you can discard them by selecting this limit. So if I run the design, we will see that the peak power went down. It was 48 before, if I'm not wrong, and now it's 44. And also you can apply earthworks in both directions, in the north-south direction and the east-west direction. Also, something that we are working on currently, we are here. You can see that we don't differentiate between north facing slopes and south facing slopes. This is something that we want to launch this year. Hopefully, before the end of the year, we'll have that, or even before the end of this month, maybe we'll have that tool available for you, so you can differentiate between the structures that are pointing to the north and to the south. So for example, here in this case, this is a project in the where we have two positive and negative slopes. So here we have slopes pointing to the north and pointing to the south here. So you will be able to do that differentiation soon, okay, in pvDesign. Okay, we have another question here. What is the most efficient solution for energy production? Solar panels, fixed solar panels, or solar panel with trackers? Luis Silva is asking that. Okay, this is a really interesting question. This will really depend on the project and the land cost also. As we saw today, it's really important to consider the land cost. So it will depend on the country, the latitude, the cost of the terrain. We did already in the past a webinar where we were talking about how to pick your structure. I think it's the name of the webinar that I did it with Laura, and it's a really interesting webinar. I recommend you to check it so you can maybe you can get some insights on how to optimize your PV plant in terms of structure selection. Okay, let me see if we have more questions here. What is the recommendation for horizontal single axis tracker? So as I already answered, there are different, okay, let me, as I already told you, there are different parameters to consider when optimizing the fix or trackers for each design. So I recommend you to check that webinar. I'm trying to check if we have more questions here, but I'm not able to see them. So I think that's all. Feel free to ask more questions. And thank you very much for participating in the webinar and also on the poll. It was really interesting. Also yesterday in LinkedIn and today here to I really like to participate and to interact with you, because sometimes I feel like I'm alone presenting here. Feel free to ask more questions. Let's wait at least 2 more minutes. And if not, we can close the webinar here. Okay, here we have, thanks, Javier. So Javier is, I'm Bernardino, but yeah, very useful information. It's important to know the optimal, because most of the time the land use is limited, so the pitch can't be high sometimes. I wanted to know how can we export from pvDesign the SOE graphics and also the 12 by 24 matrix. Okay, so to download that data, you have to go to the comparison tool. Here, select the designs that you want to compare and click here on compare. And once you have this table, you can choose the parameters that you want to export. Okay. For example, I want to export the global horizontal radiation, the structure name, and the module name, just an example. Okay. So you choose this data and you click here on export, and you will get this Excel file with all the data. Okay. This data, and once you have this data, you can create the table that I already showed before. I can share it with you if you want. We can send it for all the attendees by email, this Excel file, where you can see how to create this table. But basically, use some functions in Excel to create this table, where we are basically using the match and index function to take this data and upload it like this, like a table, so we are able to do the plots also later. This is something also really interesting that we could implement in the future if you request it. So this can be done in Excel easily, but maybe we can automate this also in pvDesign for the future. Also regarding the 12 by 24 generation matrix, I don't know if you were talking about this, but here we also have some inside this every design in pvDesign. You can download, okay, not in this case because I didn't save the documentation, but you can download here in documents the energy yield report, no, the energy yield results in Excel. And here in this energy yield results for every design that we have generated, we can get, okay, let's open. So it's here the Excel file. We can get different tables, and one of them is the 12 by 24 table. We can see the energy generation per month, okay, accumulated generation per month. By the way, this is a bit, in January we are getting a strange energy yield production. Okay, thank you for the question. Let's check if we have more questions here. Will you add the feature to remove specific structures in the design? Okay, this is a really interesting question. We are not going to tackle this in the short term, but it's something really interesting that we want to consider for the future. So basically, as I understand, you want to, for example, in this case, discard the structures that are isolated, or for example, if you want to manually delete these two structures, you want to delete them manually. So this is something that we are not going to tackle in the short term, at least to discard them manually, but we want to improve our way of selecting the structures in the layout. So if we find some structures that are isolated, we may discard them, but not for now. Okay, this is something that we we can consider in the future. So thank you very much for the feedback. Okay, we have more questions here. Curtailment based on 5% slope, positive and negative. Sorry, Matthew, I don't get your question. You're talking about energy curtailment? Curtailment based on slope, 5% positive and negative. I don't really get that question. Also, Matthew's asking about the allineator feature model. I'm not sure what are you talking about. Feel free to send us an email so we can check all the details. Also, we can schedule a call if you prefer to see all the details, okay? Okay, so yeah, here we got an answer of the question that I was asking before. Yes, please, it will be really useful to support directly from pvDesign, or if you can share the Excel, I will share the Excel with you. And if you can share the webinar link to watch it later, yes, we will also share the link of the webinar. So you can check the webinar and the Excel file. Thank you everyone for all your questions and for participating in the webinar. So let's see you in the next one. Bye.